Driving shape data. So in this video I wanted to spend some time about how to drive curves, NURBS curves. If you have a NURBS curve, and this one has a degree of 3 with 4 CVs, when you want to use this in a rig and want to deform it, I see a lot of people still using clusters to drive the CVs of a curve. Maya even has a shortcut for it. If you press Control and then the right mouse button, you have the cluster option, which creates a cluster for every CV on a curve. But if you look in the node editor, you see how many nodes are created. A cluster deformer for every CV. It's a whole deformation chain. The cluster handle has a lot of offset matrices and other stuff happening inside, taking up a lot of calculations, where we actually don't need any of this to drive a curve. If we undo this and we look at the clean curve, if we look at the shape node in the node editor and we press 3 to expand, we can see it has an attribute which is control points. These are actually positions that can be used to drive the CVs, and there are 2 modes this functions in. If you create a locator, for example, to make it visually more clear, and if we take the translate of this locator, maybe let's put it to the side first. If we take the translate and we plug it into the control points 0, you can see that the first CV of the curve is snapped to the position of the locator. And if we look at the CVs, you can see that it's actually at that position as well. Maybe in the attribute editor, set the component visibility on for the CVs so we can see them even though we don't have component mode enabled. So we can do the same thing and create another locator and take that position and plug it into the second control CV. So this way we can drive a CV with positions without having the need for clusters or anything. So if you're going to drive a curve where you need control over every CV, you don't need clusters. You should drive the control points directly. If you have a curve or another object where you want to drive, let's say, 5, 6, 7 CVs all with the same transform, then maybe you can look at a cluster, because then the difference is going to be well, not as much as this. This control points attribute basically sets the CV position internally, but it does that in a specific way. If you, for example, have a connection to the input data of this control curve, so let's maybe duplicate it for this example, and if we would take the local plug, the out local of the curve, which is basically its data, the CV data of the NURBS curve and the degree and the knots and weighting, etc. If we take that and plug that into the create plug of the other NURBS curve, this is basically the input data which creates the curve. Now you can see that as soon as Maya updates, you sometimes have to break a connection for it to update for Maya. So let's recreate the connection again. So now you can see that the original curve, that is the input, is now using the control positions as offsets. When I put the locator at a position of 0, both of them, you can see that both of the curves match shape-wise. And if I now move this locator, it acts as an offset. So the translation or the vector is added to the CV position of the incoming shape. So it has a different way of working depending if the create attribute is plugged in. So this sets the internal curve data, and then this is additive. And if you don't have a plug connected. Again, you have to move something for Maya to update. Then these are basically used as the actual CV positions. So this way you can quite easily drive a curve. And this does not only work on curves. So for example, if you would, let's write this, if you would have a NURBS surface, for example, a plane, which has CVs as well. So you can see these are all the CVs of the NURBS surface. If you look at the NURBS surface shape, it also has a control points attribute. And if again we create a locator and we take the position translation and plug it into the first plug, then again you can see that this works as an offset to the NURBS surface, because the NURBS surface create attribute, so the data is set by the make NURBS plane node, which basically creates the geometry data to create a plane. If we disconnect this and then again move this to update, you will see that the CV position of the NURBS surface is directly driven by the locator. So this way you could, for example, if you would have this locator, let's move it here, and then create a multiply vector by matrix or point by matrix. If you would plug the matrix of the locator into the matrix and then set the offset, let's say this is the matrix and we're going to multiply a point. We want the CVs of this NURBS surface to follow a specific position. So let's say we want this first CV to be here relative to this control matrix. Let's say the locator is a control. So the offset vector would be -1 or 1 in the z-axis. So if we would set the z value to 1 and then take this output and plug it into the first CV, you will see that the position of the CV will be at this point. And if we move the locator or rotate it, it will nicely move along. So we can create another node like this, another multiply point by matrix, add the matrix in, and then maybe set this to 1/3, and then we have to refresh the inputs, and then if you want to know which CV is what number, you can in the control or in the channel box, if you select the components and you select them, you can see here CVs, click to show. You can see that you now have selected the 0,1 component, which is the 0 in the U direction and 1 in the V direction. First you have the U rows. Let's say this is the first, the U0 row, this is the U1, this is the U2, and this is the U3, and then you have the V rows, this is the V0, V1, and so forth. So I'm not sure which is the V or the U row right now, so it should either be 0.1 or it should be 0.5, because you would have like 1, 2, 3, 4.5. So let's just see if it is this one. Yeah, so it is the V direction is in this direction. So once we know this, we can add another node like this and then take the matrix and then set this maybe to be -1/3, and then take this and plug it in here, and then we can add another one and in the same manner set this to -1, and then take the output and plug it into the CV like so. And now we have created the equivalent of a cluster on 4 CVs, but in a different way. So if you're, for example, using a ribbon in your rig, you set the direction in the length of the spine to be cubic and the length in the width to be linear. So you only have 2 CVs in the width direction, and you can easily, with 2 multiplied point by matrix nodes, constrain the NURB surface to the controls that are driving the NURB surface. So this works for curves and for NURB surfaces, and as well there's more nodes. For example, if you create a polygon cube, this as well has the option to drive its control points. However, for meshes it works a little bit different. If we now create another locator and you take the position and plug it into the control points, you will see that as soon as you plug it in, it will switch to the points. So you can plug it into the control points, but it will automatically connect the plug to the points array, and this always works as an offset. So you can see I can drive the vertex as an offset, but not as a direct input. So even if I disconnect the mesh and I reconnect the plug to the points 0 attribute, it always works as an offset. So as long as this is 0, it's in the original shape, and when I move it, it has the offset. So if you wanted to have a direct position to drive the CV, so you want it to be 1 to 1, you would have to change the shape of the mesh so that all the vertices lie on the origin. So if you would take this and scale them down, and then we have to disconnect this first, like so. And if we now have the new mesh like this, but if we now plug in the translation into the CV0, you can see that the position is not working correctly still, because when you modify the shape by scaling it or moving the vertices, these modifications are stored as vertex tweaks on the shape node. So it still has the same position, and if you drive the point position, you will get the offset of the original position of the cube still. So what you need to do is, when you have the correct shape, like all the vertices on the origin, you have to run a command which is called polycollapse tweaks, which basically removes all the tweaks on the shape node and bakes the vertex positions to the internal shape data of the node. Once you have done this, you will see that if you take the translation and plug it into the first control CV, that now if you select the mesh, you will see that it is exactly at the correct position. And let's create another locator so we can see it more easily. Take its translation and plug it into the second vertex position. And now let's move that away so we can see actually some geometry. So now you can see you can drive directly the CVs of the mesh. So even as well, if you want to drive a simple geometry with only a few vertices, you don't need to use clusters. You can drive the vertex positions directly like this. And as well, there is a fourth option. Let's hide this. Let's say, for example, we have a, let's create a sphere, and then we create a lattice deformer, and we set it to have 2 by 2 divisions, for example. This lattice has some inputs as well. If you look at the deformer itself, it takes a lattice base shape and a lattice shape, which are the shape nodes of the lattice and base nodes that you see in the outliner as well. And if you look at the lattice shape, you can see it has control points as well. So in the same manner, we could create a locator like so, and we could say, all right, this locator should be at the top of the deformer, and then we create a multiply point. Why not multiply point by matrix? We plug in the matrix, and then we're going to look, okay, right, what's the position? Let's see, this CV. I think for lattices they are numbered 0, 1, 2, 3, and then for the next row 4, 5, 6. So let's see if we set the output of this into the control. So it would be the 5th point. Sorry, the 4th point. So it's a 5th point, so it has index 4. So if we set that, no, it's not that one. Let's see. So this is always a little bit of figuring out. I forget the order as well. So it is the 3rd is in the upper part. So it's basically, maybe it's logic as well. If you look at the lattice deformer, it says the divisions are S, T, and U, which is basically the X, Y, and Z. So it first has the X side that is built up, and then it moves to the other side. So, but basically, this is always a little bit figuring out, but you can see where it ends up. And now we need to set this position to be the correct offset. So if the basis of the lattice deformer is the origin at this point, so the control that we're driving it with is already moved one up in the Y direction. So we have to correct that by moving it down 1 in the Y direction. So -1 in the Y direction. Not -1, but -1/2, of course, because the height is 1 of the deformer. So, and then we have to move in the Z -1/2, and the X is -1/2 as well. So -1/2, and then -1/2, and so forth and so forth. So now we have the locator in this case, which can be a control to drive the lattice point. And we can duplicate this as well. Again, plug in the matrix, and then take the, I guess it's this point, yep. And then we have to correct to not be -1 in the X, but +1/2 in the X direction. And now we are driving 2 points of the lattice, like so. And then if we wanted to do the other half, if we selected show controls is 1, 1, well, it doesn't make any sense logically, which is the order. We just duplicate this. There is a logic to this order, because it's basically creating these CVs in according to the divisions. So once you have figured out the order, you can easily extrapolate which is the next one. And I assume that it's this one. Yep. So we want to be negative in the X direction, and then positive in the Z direction. So now we have constrained 3 points. Now all this we have to do is this one. And for this one, I think it will be this one. Yep. And then we have to be positive in the X direction again. So now we have just the control, and then we only have 2 multiply point by matrix nodes, which drives the lattice directly. So we have the upper part rigged, and this way we can drive our lattice as well. You could do this with a cluster, of course, but I think this is still faster than using a cluster, and it produces a cleaner node graph, to my opinion. And you could do this with the amount of control points that you have. So that's it. I hope you apply this in your rigs, and I just wanted to share this because I see clusters being used way too often where they are not needed, as you have seen just now.